Hey, hi. In this video, I'm going to show you how to deploy AWS EKS cluster using Terraform Cloud and GitHub Actions. As you see in this PPT depicts my demo. Here, I'm going to show you like how you can, write the Terraform code and set up the CI/CD pipeline at GitHub to deploy the AWS, EKS cluster management with using infrastructure as a code, right? So here, this PPT design diagram, which will show you like how I'm gonna set up the infrastructure at at the GitHub and Terraform Cloud to manage the EKS cluster, right? So the solution would work something like this. We use GitHub for source code storage purpose. That is our infrastructure as a code or Terraform file storage purpose. Yeah, and also we're going to define our GitHub actions, definitions in the GitHub itself, right? So that's where the developer parts come in picture. So where the developers will be developing the AWS EKS cluster management with using Terraform. Yeah. So here we're going to cover very basic like how to spin up the AWS infrastructure, that is AWS EKS cluster infrastructure with using Terraform, and eventually makes it like infrastructure as a code managed, right? And then so then we will have a GitHub action workflow file which actually compiles these and runs these Terraform file, and eventually so eventually it also interacts with the Terraform cloud. So we will have a Terraform cloud subscription where we will create a workspace. In that workspace, we're going to store the state of the AWS EKS cluster, right? And that's where the even the CI/CD pipeline will interact with the Terraform cloud, and the Terraform actual the invocation or the run of the Terraform cloud happens at the run of the Terraform files happens in the Terraform cloud, which actually spins up the AWS EKS cluster, right? All right. So that's where the flow is something like this. We will have a source code here in the GitHub. We will have a state file in the Terraform cloud, and we will see the Amazon EKS cluster up and running fine. Yeah. So that's the basic the ori about the the solution. Now let me take you to the my source code. Okay, so this is my source code which I have already cloned in my so in this Visual Studio Code. The my GitHub action or GitHub repository is something like AWS EKS labs. I'm going to share these files in my videos description. You can find it these source code files from from the videos description, links being given down, given here. Yeah. So here if I go to the my repository which we created for this demo purpose, that is AWS EKS labs. Okay, this is a public repository where it actually construct the this repository has the files and folders needed to deploy the AWS EKS cluster, right? So the .github.workflows contains the the workflow files which actually compiles the Terraform code, and then the modules is nothing but the modules which is needed to deploy the EKS cluster. Main and output and provider for files are the files respectively which actually creates the EKS cluster, right? So I have cloned this repository in my Visual Studio Code. So this is how it looks. Now what I do is I'm going to walk you through the code very basically, and to help you to understand like how does the invocation happens within each other in the Terraform file and with the the GitHub action file. And then we're going to show you like how to create and set up the the TFC workspace as well. Finally we're going to run the these workflow file, and eventually we see that the infrastructure is up and running fine in the AWS account. So as I said, so the first one, let me walk you through the the source code first. That is the piece of code which is responsible for managing the infrastructure, right? So for now we ignore .github/workflow meantime. Yeah. And then we're going to go to the other files and folders, that is modules and then main.tf file. So the main.tf file here in my code, it actually calls the module, in the sense the module invocation happening in this main.tf file. So here we have created the two modules. One is the basically EKS, the other one is the VPC. As the name says EKS, this is the code which actually creates the EKS cluster, right? And as you see, I'm invoking the modules because I have created a modules like modules, right? And that's the reason the source path is pointing to modules.eks. Then we have defined the subnet required for EKS cluster, that is public subnet. Note that the cluster which I'm spinning in this demo is public cluster, while in my next iterations of my videos, I'm going to focus more on private subnets, private EKS clusters actually as well. Yeah. So here we will have the VPC ID, cluster name, the endpoint, private endpoint. Yeah. Then we have the public CIDR. Yeah. And then the node group name, the scaling desired state. Yeah. So basically, and then we have a maximum and minimum scale set definitions, and the instance type. Here I'm using T3 small because this is a demo. Yeah. So and then we have VPC module. So VPC module is pointing to the folder structure. That is, if I expand this one, we have a EKS and we have a VPC, right? and that's where it is pointing, and it has these many parameters, that is tags, instance, the instance tenancy, VPC CIDR, and the access IP address, right? And the public CIDR ranges. So basically, so this is the VPC CIDR. We are breaking that into two public subnets like /2424, right? So we are creating just a smaller chunk as the public CIDR out of 4/16, and then we have a route table CIDR range as well. So as I said, this is a public cluster. That's the reason we will gonna have certain further resources of VPC to make the EKS cluster public. All right. So this is all about the main.tf file. If I go to the output, so we are actually outputting certain things, that is cluster ID, cluster endpoint, and the cluster names. Yeah. And in the provider block, so the provider block is very, very important block of your the infrastructure as a code. So here we have a Terraform block. In the Terraform block, we are actually dumping, we are actually accumulating the required providers. So here the providers are AWS, random, and Kubernetes, right? And then within that, there is a one more parameter in the Terraform called backend, in the sense where actually you are storing the state of your the EKS cluster. So here my state is getting stored in a remote place, that is, and the app.terraform.io, which is nothing but it's a SaaS service from HashiCorp, which actually stores the state of your infrastructure remotely in a space called workspace. Okay, so generally the workspace, yeah, so we give the workspace name as AWS EKS cluster. I created this workspace and I have configured. I'm going to show you immediately after this, right? And then we're going to have the data, that is the cluster data, cluster authentication, which I'm just collecting to set up my Kubernetes providers. In my next iteration of the videos, this video, I'm going to help you with how you can deploy the applications, say observability applications or normal the cloud native applications of Kubernetes on EKS cluster, how you can deploy those. Okay, so I will show you ahead in my new videos, okay, in my further series of videos around EKS. So this is what it actually set up the provider, or you can consider this is the block which actually creates a kubeconfig file for you. And then we have a provider for AWS. I'm using deployment in US West 2 region, that is Oregon region. Then we have a random provider resources. Okay. All right. So these are all the so basically these are three main three .tf files which are created directly underneath the source code repository. This is our source code repository, and underneath that we are directly having these three the files. And then I'm going to walk you through the modules, folders, and file structures as well. First module, let's go to the modules / EKS module. So as the name says, EKS module. So this is the module which actually creates the resources needed to spin up the EKS cluster. So first one is we are creating the AWS _ EKS _ cluster. That is basically this is the the Terraform code which actually creates a cluster for us. Here we are providing the name and the role name. So these are all the values coming from the main.tf file when it actually invokes the module, right? And the name, role, and we have a VPC config. In the VPC config, we have the subnet IDs, endpoint, public access, public CIDR, yeah, security groups, blah blah, and all. And it also depends on the the role ARN, right? So to attach a role, you need to have a policies attached to that ARN, the role which we are creating here, right? That's the reason it also depends on a certain policies. So this is actually creates a EKS cluster. Now let's go to down the another one. So cluster creation is not enough. So we also need to create a EKS node groups as well. So this is the block which actually creates the EKS node groups. It contains the cluster name. You need to provide your node group name, node role ARN, and the subnet ID, instance type, yeah, and then the remote access configurations, scaling configurations, and depends on configurations are being given in this file. Okay, so basically this is actually creates the node group of your EKS cluster. That's the reason we have a dependency here. If you see here, that is AWS cluster, quick labs, and then the names. Yeah, that's basically that becomes a implicit dependencies. Yeah. All right. So this is EKS cluster. Then we are creating the security group. All right. So in the security group, we are adding the ingress and egress rules. That is, we are actually allowing the TCP port, that is 800 ports to the internet. And we have a egress which is actually allows everything. That is, we are creating a custom the node group which will be attached to a node groups, basic custom security group which will be attached to a node groups. So how it is attaching, you can see here, basically security group. So if I select this security group, let's see how it has been pointed. So these security groups are being consumed down the line. If I go down, so we have a dependency. Yeah, basically this security group is consumed in the remote access configurations of the node groups. All right. So that's about our security group configuration. Then we have IAM roles. So we are actually creating two IAM roles. One will be attached to the cluster. One will be attached to basically to the node groups. One is the IAM role which the trusted to the EKS cluster. right? That will be attached to the EKS cluster. Yeah, and this so basically this role will be attached with the policies like Amazon EKS cluster policy plus Amazon EKS VPC resource controller policies will be attached to it. And then we have so we also have a node group IAM role which is trusted by EC2 machine, because node groups is constructed by the EC2 machines only, right? And then we are attaching the three policies to it, that is EKS worker node policy, CNI policy, and then the the registry, the EC2 container registry read only policies are been attached to this one. Yeah. All right. So with that, we have two other files which actually print something, that is does the output, and then we have a variables which we are basically given as an input from the main.tf file. All right. So all these like public subnet, VPC, CID, all these information would be fed from this main.tf file. You see these are the parameters which we are passing is equivalent to the parameters which we are declared in the variable.pf file. All right. And similarly, let's go to the let's go to another folder or another module underneath modules folder, that is VPC module. So in this module, we are actually creating the VPC and subnets plus internet gateway, because this is a public subnet. So here we are creating the VPC with the CIDR that is being given from the VPC module invocation. Yeah. And then we have an internet gateway. So we are creating this internet gateway here. So if I can do this like this, yeah, we are creating the internet gateway here, and attaching that internet gateway to the VPC which we created above. Then we are actually finding out the availability zones of the region. Okay, those availability zones will be used down the line to to actually distribute the subnets of the VPC. That's the reason here. So this is like a dynamic subnet creation resource block actually, which creates two subnets, because we have a subnet count equal to 2, and it is attached to those subnets are being carved out of VPC which we are creating above. Then we have a default route table, so which is actually creates a route table. In that one, we are actually adding the routes, that is this is the CIDR route and gateway route. Yeah, basically something is been configured here. And then finally we are actually associating the route table to the to the subnets. So the AWS subnets, if you go to the AWS subnets here, in that one we have a quick lab subnets, and we are actually the attaching this route table routes to the subnets. All right. So basically that's all about the configurations of the VPC. In the sense, this piece of code is actually helping you to create a public EKS cluster. In the sense, this is bare minimum configuration you need to be keep in place to make the AWS EKS cluster up and running fine. Yeah. All right. So this is smooth enough that it actually creates a EKS cluster. While while your requirement could be changing here in these files, you just need to go ahead and create the respective resources, make this module more usable, or make this module adaptable to your use cases as well. Then let's go to the the github./workflow file, which actually the file which actually invokes or compiles our Terraform file and spins up the AWS EKS cluster. So here I have a 3.yaml file, or basically workflow files. Don't get confused. I am just mimicking the reusable workflow methodology to run those the EKS cluster, right? So here then my name is 01 EKS cluster, and this EKS cluster will be invoked on workflow dispatch, which means that will be invoked during the if you are manually invoking. Then you have a plan, and then you have a apply as well. So plan is pointing to the I have a two files with the name like AWS_TF_plan and AWS_TF_apply, right? So all those two files will be invoked, right? Basically plan will get executed first, and then we will execute apply. So first let me go to the plan. Basically this actually does nothing, but it actually just compiles these files. In the sense, it just runs the Terraform plan from the folder that is AWS EKS labs. All right, so here the name is build tf plan, and the workflow call. So when on workflow call, it actually expects the 2 or 3 inputs, that is tf version and GitHub environment. Yeah, since it is a reusable, I have created environmental option as well here. All right, similarly let's go to the jobs. In the jobs, it's very straightforward job. So it runs on the Ubuntu latest, and environment is the environment which we are parameterizing, then runs on a bash. Yeah, then we have a steps. First one is checkout, setting the Terraform. Setting the Terraform with the TFC CLI token. So this token, I'm going to show you how you can create that. And then we have a Terraform init, Terraform apply commands. Yeah. Likewise, Terraform apply does the same thing, but extra thing that it does is Terraform apply. Yeah. So that's also basically I have very quickly walked you through the another code base that you need to set up and how these are connected to each other to spin up the AWS EKS cluster infrastructure at AWS. Now let me take you to the my my Terraform cloud subscriptions. This is my Terraform cloud subscriptions. I have an organization called Cloud Quick Labs, which is equivalent to my channel name. And then we have a workspace. In that workspace, I have created a workspace called AWS EKS, right? So in this workspace, if I go to the variables, I have set the as usual the variables, that is AWS key and secret will be set here. Okay, so don't worry. So I have exposed these secrets anyways. I'm going to delete these secrets after my video has been created. You don't need to try it. All right. Okay, so basically this is how I set it, my secrets. Yeah, and my so if you see here, I have already compiled the code, and the last compilation of the code has went green, in the sense it has successfully applied and the infrastructure is already been spinned up here. So if you go to the see the apply finish, in the sense my infrastructure is up and running fine. Yeah, since we made some changes, I'm gonna show you that this piece of code does work as expected, and it also spins up the infrastructure in the AWS as expected as well, right? So I will say like demo changes. I will just say demo changes. I will commit this and I will synchronize into the to the upstream branch. All right, once it gets synchronized, I'm going to invoke the workflow file manually. So if I go to the my AWS sorry, this is my the GitHub repository. In that one, AWS EKS lab is my the repository which we were talking about, and the folder structure that you see in the Visual Studio Code is equivalent to whatever you see in this the GitHub. Right, so you have a main, output, then provider, then we have a module and workflow file. Okay, so if you go to the GitHub actions, right, so here is the your workflow. So this workflow is the manually invocable, right? So yeah, so basically, as I said, so once your workspace is being created and you configure the environmental variables, right, and what you do is you need to do one more thing, is basically go to the so go to the user settings and have a token. So basically, I have also created a token, something like this, which is going to expire in 25th November, right? And this token is being used and set as a secret in the GitHub environment. In this sense, this is my repository. In this one, I have created an environment called dev. In this environment, I have created a secret called TFC API token. So you must do this, or else the code invocation gets failed, for your information, right? So with that note, I have already covered every and each and pieces of the work that you need to set up to spin up the EKS cluster. All right. So with that note, what I do is I'm gonna go ahead and run the workflow to give you a real-time demo. So here I just invoke the EKS cluster. Let's see how does it works. If you see here, the invocation of the EKS cluster, basically the compilation or the the execution of the Terraform code, it has now started from the GitHub actions, and the GitHub action is performing these stages. So I have a two stages here. That is, one is will plan it, and then another one will run immediately after it. Yeah. So basically, if you see here, the currently we are actually seeing the Terraform plan, and if I go back to the Terraform minute, it actually successfully connected to the remote backend, that is TFC. Yeah, then we have a validation is also passed, and then we have a plan which is getting executed. Right, so currently it says there is no changes, right? So with that note, in the sense, basically, since I didn't modify in the Terraform cloud, so basically I didn't modify the Terraform files, so that's the reason the infrastructure matches, and it identified that there are no changes. We should expect same thing from the Terraform apply as well. So let's see how does the Terraform apply works now. So if you see here, the first plan got executed, then it is running the apply. So why did I do in a two stages? Because the plan will just draft your infrastructure, and it will tell you, hey, I'm going to do these changes. At that time, you can read the summary, and then once you are satisfied with the summary, what Terraform is telling you, then only you can click on a button like apply. That's the reason I divide Terraform plan and apply into two stages, so that you get a gap of approval. So in the sense, in between you can keep a approval options as well. In the sense, to apply, you can keep it a approval option, so that your infrastructure remains safe always, and your application ups and running fine always. Yeah. So here you go. The infrastructure is already been matching the the configuration. All right. Now once the apply is up and running fine, I'm going to take you to my AWS account, and we're going to see the infrastructure. So looks like Terraform apply has been gone green now, which means that it has applied successfully. So let's wait for a couple of seconds. to complete the Terraform apply. And then I'm going to take you to my AWS account. As you see here, even Terraform apply says no changes. All right. Looks like the pipeline has gone green. It is taking time. I think, yeah, now it is done. All right. Looks like now it is done. If I go back to the, here you go, the plan and apply has went green. Yeah. All right. Now let's go to the AWS account and see the cluster. So currently this is my AWS account where I was provisioning the infrastructure, that is EKS infrastructure with using Terraform. You see the my cluster that is of version 1.27 is been up and running fine. If I open this, it looks like every configuration. We have created a EKS role. This is like this. We have a resource, we have a compute. If you go to the compute, we have a node group as well. All right, so and then the node groups, everything has been as expected. Configurations. If I go to the VPC, we have a VPC with a name like Cloud Quick Labs, right? And it has a CAD range of /16 10.0.0, yeah. And we have a 2 subnets, yeah. Name is something like this. If you go to subnets, we have a 2 subnets of VPC this, yeah. And then we have an internet gateway as well, which we created, and then we have a the route table as well. All right. So which actually, what does this mean? In the sense, I have so basically we have managed to create the the AWS EKS cluster, that is managed Kubernetes cluster. Infrastructure is now managed with using infrastructure as a code, with using GitHub, GitHub Action, and Terraform Cloud. All right. So with that note, I have successfully shown you the things need to be shown in this video. Finally, I can request please do subscribe my channel. That would really encourage me a lot. So with that note, thank you, thanks a lot, and see you in the next video.